Hello, this video is about hypothesis testing. Previously, we have seen what is hypothesis testing and z-test, three types of t-test, and also two types of ANOVA test, which is one-way and two-way. And now we are going to get into chi-square test. So chi-square test is where you use categorical variables so we have two types. One is a goodness of fit, where we compare the observed frequencies versus the expected frequency, or what is the frequency that is supposed to be. We'll get into an example as well. And the second one is test of independence. So we are going to see if the categorical variables are impacting the uh, output, and if there's any correlation. So yes, again, we'll get into an example so it gets much easier and clearer. So let's see the first one, winners of fifth, which we are going to see if a dice is fair. So if you know a dice has uh, six different sides, or six values, right? So you know it's 1, 2, 3, 4, 5, 6. Every time you roll a dice, you're going to get from either 1 to 2, 3, 4, 5, 6. So, and if we have to conclude that this dice is fair, we have to make sure that each of the value of the dice have equal probability when a dice is thrown. Let's say we throw the dice about 30 times in a row, and each of the values should occur at least 5 times to call the dice a fair. So this doesn't really happen in a reality. There's going to be slight difference in the event that occurs. Sometimes you might get four times, and six 5 times, and three 6 times. So that's where chi-square comes into picture, where we test it out if if the observed frequencies and expected frequency are fair or not, and if the you know the if there is if it's a fit event, or is it biased in a way. So let's get into a practical example. So here we're going to use Scipy. Let's import chi-square. So observed frequencies. So let's say this is again 1, 2, 3, 4, 5, 6, and each number, how many times it occurred during the trials. So this is 1, 2, 3, 4, 5, 6. 1 occurred 17 times, 2 occurred 15 times, and so on. This is the observed. But what is expected is all have to be equal. So each gets equal opportunity, right? Into the total sum of observed frequencies. So what we're doing here is we are taking a sum of this. When we take a sum of this, we are going to get a value, like, which is this 100, right? And when we take a sum of this, we want each, so we're going to get this particular value and divide it by 6, and we are going to put it up in a list, and when we multiply it by 6, we are going to get 6 values. So each should have a frequency of 16.66 in this particular case. That's what we did here. And once we have this, we're going to compare it with chi-square. So let's call it out. So we're going to pass two arguments, the observed and also the f expression, which is the expected frequency. And now we'll be able to see that the statistic value is here and the p-value is here. So now let's just assign it to chi and p-value. We'll see. Basically, we got these values, and we have set our alpha value to be 0.05, and now if we compare it, you'll see that if we reject the null hypothesis, it means there is a significant difference and the dice is unfair. If not, the dice is fair. And you can see that we are accepting the null hypothesis since the p-value is greater than the 0.05, which is the alpha value. Hence, we can say that there is no difference between the observed frequencies, and there is no significant difference, and the dice is quite fair. So yeah, that's pretty much about the goodness of fit test in chi-squared, and we'll see you in the next video.